Here two identical galvanometers are given, and resistance of both the galvanometer is 10 ohm. Then the current, maximum current measuring capacity of both the galvanometer is 2 microampere. So naturally the maximum voltage measuring capacity of them will be 2 into this 10, so it will be 20 microvolt for both of them. Later on what they did, they have converted one galvanometer into voltmeter for measuring the 100 millivolt as a maximum voltage, and another galvanometer as an ammeter for measuring 1 milliampere as a maximum current. It is also said that these are used to measure the voltage and current in Ohm's law experiment with resistance equal to 1000 ohm by using the ideal cell. So later on, these voltmeters which you have converted into 100 millivolt maximum measuring capacity and 1 milliampere maximum current measuring capacity, these are then used for the experimental purpose across the resistance of 1000 ohm. In that case, what is going to happen, that we have to check from the options. Now the first option says that the resistance of voltmeter become this and the resistance of ammeter become this. So these two are very simple straightforward question. You just have to remember the formulas and you have the answer. Now what is there for the voltmeter? So whenever I convert it into voltmeter, I always connect it into a resistance, that is a series resistance RS. And whenever I convert it into an ammeter, we always connect a shunt resistance in parallel with this. So what we have to do is we'll have to first find what is this RS and this shunt resistance, and then we will find the net resistance of the voltmeter and ammeter. Now for finding that, we have the formula that RS is equal to G into N minus 1, where the G over here is 10, and what is N? How many times you are increasing its measuring capacity. So it was 20 microvolt and now you are making it 100 millivolt. So this is 20 into 10 raised to minus 3 millivolt, and this is minus 1. If you solve this, it will become 5000 minus 1, so 4999. Means it turns out to be 49990. This is the series resistance RS, and therefore what will be the resistance of the voltmeter? So RV, I'll just put a notation for the resistance of the complete voltmeter will be RV, which will turn out to be this G plus RS, means 49990 plus 10, which turns out to be 50k. But what is given here, that it is 100k, so this is not the correct answer option. Similarly, for the ammeter, you have the relation that shunt resistance is equal to G upon N minus 1. Now here it will be 10 upon. Now what is N here? So you are measuring, increasing the capacity from 2 microampere to 1 milliampere. So it is nothing but 1 upon 2 into 10 raised to minus 3 minus 1. So it turns out to be 500 minus 1, so 499, means 10 by 499. Now what will be the net resistance? So resistance of the ammeter. Now this is going to be, it will be S into G upon S plus G. So if I solve this, it will be 10 into 10 upon 499 divided by 10 plus 10 by 499. Now if I multiply by this 499, it gets cancelled out. So it is 100 by, this is going to become 5000. So it is 1 by 50, so it is 0.02 ohm, and hence the resistance of the ammeter, which is given as 0.02 ohm, is the correct answer. Now once you finish these two, this is slightly different. Now what they have asked here is the measured value of R such that it lies in between this. Now what they are saying is that whenever you use this voltmeter in parallel with this 1000 ohm resistance and you connect the ammeter in series, then you connect a battery of say EMF E with negligible internal resistance. They have said somewhere here, these are used to measure experiment with by using the ideal cell. Ideal cell means what? It is having a negligible internal resistance. So now I want to find that what will be the measured value of resistance. Well, to find that, now I'll consider both the options, because in second option what they are saying that you are using, instead of ideal cell, you are using a cell of resistance say R. So what I'll do, I'll generalize it. For the fourth option, this R equal to 0. And for the third option, this R is nothing but 5 ohm. So I'll just put that as a variable, say R. Now what will happen? The current which is flowing in this is, say, I. So the voltmeter, whatever it is going to measure, is that the voltage measured, I'll just write here that voltage measured will be I into, this is going to be 1000 into resistance of voltmeter upon 1000 plus RV. This is the voltage measured by this voltmeter. And how much is the current measured by this ammeter? So current measure is going to be I. So what will be the effective resistance measured using these devices? So the resistance measured is going to be this upon this. So finally it turns out to be 1000 RV upon 1000 plus RV. Now it is the same answer irrespective of whatever value of R is. So it is independent of R. It has no relation, because again I'm repeating, this voltage, what this voltmeter is going to measure is I into this effective resistance. So it is 100 into RV upon 100 plus RV. This is resistance, and that resistance into this current is voltage across the voltmeter which it is going to measure. And the current what it is going to measure is simply this current only. And you want to solve the answer by looking at the value of voltmeter and ammeter. So simply I'll take the ratio of both of them, and it turns out to be 1000 RV upon 1000 plus RV. And hence the answer for the measured value of resistance will be same for both C and D. Now how much that value turns out to be? Well, what is the value of RV which we have calculated? It is 50k. Now if you substitute this 50k here, then it is 1000 into 50k upon 1000 plus 50k. If you solve that, then it turns out to be 980.39. Now 980.39 means it definitely lies in between this range, so D is correct. But what they have said here is the measured value of resistance will be greater than 1000, which is incorrect, because even in this case it is going to measure 980.39. And hence the correct answer options for these questions will be B and D.